Let's monitor a J1939 CAN Bus battery charger data on the powerful yet lightweight Ubidots dashboard, transmitting our data remotely over a cellular 4G network. This video will take you through all the steps, from physically wiring up until you send your data to your designated server or cloud service. In our case, that is our dashboard on Ubidots. You can also skip to any chapter in this video to narrow your focus on any particular steps along the way.
We will be connecting our battery to a battery charger, which is attached to our power source. We will collect and convert the CAN bus data into a JSON format, saving it on our gateway's onboard SQL database. From there, the data can be processed and sent to a cloud or server over a cellular 4G network. You have to refer to your own device manuals for the exact wiring details, but this is a useful schematic to follow for your setup. A copy of our network diagram is available for download in the description of this video.
The Node G5 is a sleek, industrially certified MQTT gateway with integrated AWS, Azure, and Ubidots clients for edge monitoring projects in demanding environments. It measures only about 130 by 80 by 25 millimeters, which is around 5 by 2 by 1 inches. You've got this rugged aluminum shell and a twist and lock power cable designed to withstand some significant level of knocks or shaking. This ARM IMX8 Plus Debian gateway gives you the ability to combine monitoring for the following types of industrial protocols: CAN Bus J1939 and OBD2, Modbus RTU and TCP, Serial RS485, Bluetooth and Wi-Fi either as a client or server. Users have the option to select up to 2 CAN bus and 2 RS485 ports to fit the requirements of their projects. We have more example tutorials for connecting different types of industrial devices to services like AWS and Azure available on our website, and there's a link to that library in the description below. You'll also find our Python API guide and REST API tutorials for those interested in that. We'll also be adding more of such tutorial videos to this channel, so if you find this useful, you can save it and subscribe to get notified when we post up new content. We want to start by matching the baud rates of the battery charger with the gateway. We'll do this using the gateway's web configuration interface. Since we've already connected up our laptop to the Ethernet 0 port of the gateway, let's open up our browser to our default URL 192.168.1.1. The default username and password will be admin and node 12345. From the axiomatic user manual, I know that its baud rate is 250,000. Let's mimic this on the gateway. Go to the serial CAN page using the left navigation pane. We've connected up the charger to CAN port E earlier, so let's go ahead and type in 250000 here. And then click Update. Next, we'll go to the IoT hardware page. Then let's select J1939 mode from the CAN bus drop-down menu. Again, let's click the Update button to save the settings, and then we'll reboot the gateway to implement those changes. Next, we'll head back to our Web Config menu. Click on the Cellular 1 tab. Select Cellular as your primary one interface. For this next part, you'll need your APN information from your internet solution provider. I'm using Telstra, and the APN for my service is Telstra Extranet, so I'll type that in here. You can add a further watchdog feature for network robustness with this Reboot on Ping Failure feature by designating an IP address, such as Google for the Node G5, to continuously ping and check its connectivity. But we'll leave that section empty for now and just click on Update to save the settings, and then we'll reboot the gateway to implement the changes. To configure the list of data that we want the gateway to pull from the charger, we are going to use a JSON configuration file called an IoT asset. We can set up this file to monitor the specific sets of data from our J1939 device using the CAN Bus configuration guide on our website. I've also attached a copy of this guide in the video description. The easiest way to start is to scroll down and copy the template script at the bottom of this file over to our editor. From there, we'll just follow the instructions in the guide to fill in the values in the script. Don't worry if you face any issues here, as our technical support team is just an email away, and we are ready to step in anytime to help our customers along the way. If you want a further detailed step-by-step run-through of how we set up the IoT asset for specific sets of data, let us know in the comments. Now log back into your web configuration menu and go to the IoT Hardware tab. Click on the Upload IoT Asset.json file button to upload your configuration file. After the upload is successful, let's reboot the gateway. You can confirm the status of the upload is successful by clicking on the Diagnostics Check File button. Let's also test that the gateway is successfully getting data from the charger. Click the Diagnostics JSON Data button. You should be able to see the data from your charger being populated.
I've logged into my Ubidots account, and what you can see here is my user console. If this is your first time setting up, you want first to go to Users/Organizations and create a new organization. Since we have already done that, I'll go to the Devices tab to create a new device with the plus icon. Assign your device a name that you prefer and press Accept. In my example that I've created earlier, I've called it Axiomatic Battery Charger. Back in your Main Device tab, you should see the device that you've just created. Click on it, then copy the token ID generated to your clipboard.
Now let's head back to the Node G5 web config menu and go into the IoT Client tab. Let's paste the token we've copied on our clipboard under the Ubidots section and add the device name. Click on the Update tab to establish your connection to Ubidots Cloud Service. The Node G5 will now start sending the JSON data from your device to Ubidots. If you go back to your Ubidots account and look under Devices, you will be able to see your new Node G5 listed here. From here, we can design our dashboard to view the data using a plethora of tools provided by Ubidots. I hope this tutorial has been useful to help you set up your own CAN Bus J1939 monitoring application. If you have any questions or requests for other types of tutorials that you'll want to see from us, leave a comment in the sections below.